we've got a panel coming up now, routing around Catastrophe. So I'd like to invite Rob Evans, Nick Hilliard, Mike Hughes, and Dave Wilson back up on the stage, and I'll hand it over to Rob, who's going to moderate this panel. Thanks, guys.
All right, afternoon. So, the title of this is Routing Around Cats. Sorry, Catastrophes. It was blocking the paper there. Now, the internet routing system is a wonderfully stable, reliable, resilient thing, most of the time. But we'll all remember the odd incident, such as when Pakistan tried to filter YouTube, and instead of it taking hold just internally, it leaked out the entire world with a couple of /25s. I might also remember such things as a fateful Tuesday morning when a 32-bit ASN was announced and every Juniper running Junos 9.1 crashed at about the same time. So it's resilient, it works most of the time, but not all. So what we're going to try and discuss today is maybe some of the vulnerabilities, some of the problems of internet routing, what some of the solutions to that might be, whether there are some gaps in the solutions, whether the solutions themselves open up new and interesting vulnerabilities. And one of the points of this is that it's going to be open to discussion. So please, whilst the panelists are talking, whilst there's discussion going on the stage, think about your view on things, think about whether there's any questions you want to ask, any opinions you want to give. So, on the panel, we have Mike Hughes, who's been involved in the internet for a little while, currently with HEAnet Consulting, doing this, that, and the other, and has been involved in ISPs in the past. Next to him is the CTO of Internet Exchange, just too small for BT. Also involved with, quite heavily involved with Right Policy, Nick Hilliard. And then on the end we've got Dave Wilson of HEAnet, whose main hobby appears to be actively being disruptive. And with that, I'm going to ask you to kick off. I'm going to start with Mike here, and if each of you can maybe, starting with Mike, describe some of the problems you see in internet routing today, what keeps you awake at night when you think about what's happening to the internet.
What's happening to my packets, yeah. I think there's sort of two areas I'm going to focus on really, and I think one of them is fat fingers. And inadvertent errors. And then the other thing as well is we've also got inadvertent outcomes of things that you plan to do. And for example, the 32-bit AS deployment was a really good example of that. It's an inadvertent outcome of putting something out there without either the appropriate testing, wide exposure, or whatever else is required. First of all, a quick sort of show of hands. I'll start involving the audience early. Who here has ever configured any networking gear by hand? And by me, I mean typing on a VTY. And hopefully everybody should put your hands up unless you don't have Enable. And if you don't have Enable, you shouldn't put your hands up. So that's great. And who here will own up to having made fat-fingered errors in the past and turn down customers accidentally, or oh, that's the wrong port, or leaked a full table, or whatever else. And everybody remembers significant routing incidents like AS 7007. There was the incident involving YouTube in Pakistan. So the 7007 incident, it was obviously a fat finger issue. And the Pakistan YouTube incident, where they announced YouTube internally in Pakistan to try and sync traffic to YouTube locally to prevent people within Pakistan getting it. Of course, the inadvertent thing there was because of a fat-fingered error that then propagated. So there's two sorts of, there's fat fingers and then doing something that you meant to do but making an error in doing it and then causing that to have an adverse effect elsewhere in the internet. So that's good. Everybody's human. People do make errors. Of course, the other thing that comes up against is more automation as well. And so, for instance, one of the things I mentioned was root leaks. And one of the things that we did do in the past, and I think Nick might have something to say here as well, that we have done in the past that I know some people do now, is they build root filters from information that's published in various routing databases and automation. So, yeah, put your hands up if you've ever built your routing filters from IRRDB or RIPEDB or whatever else, and built them automatically and installed them into production automatically. Not that many, a few, okay. And having actually had them be installed in production and go into a production state, who actually decided that was a really bad idea and took it off your equipment? So that was one of the issues there is a GIGO problem. That's the main issue with things like the IRRDB is a GIGO problem, and in terms of the automation, bad tooling as well. So I think those are the sort of issues that we're up against. And as we consider going down routes that require more automation, and as the network grows, we have to do more automation. We go from fat fingers and simple stuff to a situation where, when automation goes bad and the automation goes out of control. So I can think of an instance where I was working for an ISP. We were a downstream customer of an ISP, a transit ISP, that made all its routing table filters from the IRR database. But they had no sanity checks on that. So it's like automation gone bad. And what happened was there was no sanity check. They mirrored all the various different routing databases that exist in the world down to a local copy. They then compiled the filters and then upload them into their router. What happened was the mirroring failed one night, so they ended up with a pretty empty database. They then compiled all the routing filters and the cron script applied them to the routers in the middle of the night, and I stopped getting much traffic through this transit provider, and I couldn't really get any traffic out through them either. So that was a real problem. I didn't really get much in the way of routes from them either. So fortunately, it protected itself in the long term, but that caused me to overfill my other circuits. So although I had multiple options to the internet, at that point, I'd oversubscribed my other transit circuits because I couldn't actually get traffic in and out through this provider because they effectively turned their network into a stone wall. So in terms of examples of things of how automation can go bad, and that was from the 90s. So that and I'm worried in my mind that how much have we learned, because we're going to have more automation in terms of deploying things like routing security and signed routes and route validation, things like that. We're looking at more automation to build config and the things around that. And is that another route for entropy that's as bad as fat fingers or worse than fat fingers? I think I'm done. We'll move on to Nick.
And maybe we'll come to that. I remember one of the first times I was on call for a job quite a while back. There's been this router with many interfaces that was clocking up errors and decided to no-shut on the interface. Unfortunately, all the many interfaces were on a single PVCs on a single ATM interface, and so I shut down the interface and then couldn't do a no-shut on it. And the POTS modem was out of order as well. Anyway, so Nick, same question, really. What keeps you awake at night?
Plenty of things. Scary cat videos being the prime problem. Routing issues do, of course, cause a lot of trouble. Being an IXP operator, we see we see two things which are scary. First of all, the amount of fat fingering that goes on is quite scary in itself. And the second scary thing is that the relationship of fat fingering to the size of the organization and to the amount of procedures that these organizations have put in place there is no relationship between the two. A big organization is just as likely to do something stupid as a very small organization, which I found to be a rather interesting data point. From the point of view of root filtering, I'd kind of like to pick up where Mike stopped. We have obviously got root servers, and they feed, they take their data feeds from internet routing databases. Over the years, we've been running these since probably 2008-ish, and over the years we've put an awful lot of effort into sanitizing the process by which this data is collected. Which is to say that we ignore most sources in the internet routing databases. There are many sources which are very good. Unquestionably, the RIPE database is by far the best. And the reason that it's the best is because there's data grandfathering inside there. So if you get a prefix object from or at least which is registered to an organization in the RIPE service region, well, then there's a good chance that the routing information in there is actually likely to be reliable. And that's because of the data grandfathering thing. The RIPE NCC will not allow you to send in an update for somebody else's prefixes because you've got MNT roots and MNT lower and that sort of thing. And this is very important from a sanitation point of view. If you take other databases, AltDB, Level 3, Savas, all of the local databases, the term that I would use for most of those is pure garbage. We just filter it out. It's not relevant, and we don't want to see those in our prefixes, partly because a lot of the information is very badly maintained, but also in the future we're going to see an awful lot of address transfers from one location on the internet to another, and the collected detritus of that is that there are going to be prefixes registered all over the place, and that's going to cause an awful lot more trouble. So you have to do an awful lot of sanitation. It turns out that actually sanitation isn't all you need, because one day we turned up a customer and they nearly took out INEX. It wasn't because they were too big for INEX, like certain organizations in the room. It was because they had done a trick that we totally didn't expect. We announce all of our root server prefixes as an AS set in the RIPE routing database, and they had included that AS set in their own AS set, which meant that when we built our prefix filter, we accepted all of the prefixes at the INEX root server from them, which would have been pretty bad, except then the next thing that they did was they announced all of the prefixes from INEX, redistributed them into their interior gateway protocol, and then redistributed them back into BGP, and then redistributed them back with their own AS number into INEX. So there was a catastrophic series of failures which caused this. I mean, I really have to take my hat off to these people for their ingenuity. Fortunately, due to a number of things, it had a relatively low impact, but we also had to configure max prefixes after that, and we do a certain amount of sanitization, or at least manual checking of filter lists before customers are put live, because the potential for disaster is great. Several organizations in the room have noted that large numbers of prefix lists on a router will not scale, and my God, they won't. Our current Quagga configuration and Bird configurations are 1.5 megs. They have, at periods in the past, been up at 7.5 megs of configuration file, most of which is just prefix lists. If we were to add in some of the really large AS sets out there, they would go up to many megs in size. And of course, the reality is you can't really configure that on most routers. You can do that with a Quagga, sort of. You can certainly do it with Bird, but if you try to feed that into you know, sort of some mid-sized Cisco IS device, you'll just trash it and it won't work. So from that point of view, a system like RPKI and BGPsec and prefix signing, these technologies are pretty inevitable from one respect, but they're only half there, because all we have at the moment in BGPsec is prefix signing. We don't have AS path signing. And because we don't have AS path signing, so long as somebody announces a prefix from with a particular origin AS, well, so long as they get the correct origin AS, that's A-OK, and they can still go about their malicious little ways, stealing somebody else's traffic. There are certain things which will help, like prefix mask lengths, but you know, the bottom line is that you're still going to be able to do a whole pile of messing around. The AS path signing problem is a lot more difficult, and the ITF at this stage has got to the point where there's a wish list. The protocol development hasn't gone beyond that, because many of the items on this wish list are incompatible with each other, and they won't work. They also cause an awful lot of trouble for root servers. How do you sign an AS path and accept an AS path which has gone through a root server which is acting as a broker, where you've got cryptography involved? I don't know how that's going to work, and I'm not sure if anybody else knows either. RPKI has developed a certain amount of controversy. There are some people who are very interested in it.
I think we might be,
yeah, sorry.
Into the solution space right now.
I don't want to go into the solution space. Anyway, these things keep me awake at night. Most of them are solvable, and being an engineer, I'm generally happy with a 90 or a 95% solution. So I lose a few minutes sleep every night.
So the takeaway from that is that some networks really are too big for INEX. So the takeaway is that some networks really are too big for INEX. And Dave?
As far as I can see, the problem is we keep sabotaging ourselves. Let me tell you my favorite shut no shut story. I had a client, an institution, who anytime, this is some years ago now, anytime his link went down, which it did occasionally, his first reaction was to treat the router the same way he treated everything else he administered, which was to turn it off and back on again. I started to get very frustrated with this, because of course I'd get back onto the router and I'd look for the logs and they'd all be gone, because he rebooted the thing before calling us and before we could get in to save anything. And then one day I was configuring his router, and I was configuring ACLs in his router and configuring ACLs on the interface that I was telnetting in on. It was telnet in those days. And of course, the inevitable happened, and I cut myself off and I went, oh my God, how am I going to solve this? I'm going to have to get him to get a serial cable out and plug it in and probably download a terminal emulator and get on. And I phoned him and he goes, I start explaining and he goes, would you like me to turn it off and on again? And I went, yes, yeah, do that. And I mean, you're right, Mike, to mention the problems with automation, but of course, manual doesn't save you either, because I've been bitten by the IRDB problem, even though there was a human being in between, and the human being pressed go on a filter that was very clearly and very badly and very seriously wrong, which not only cut off our announcements, but also blocked all traffic because of EuroPF into a decent chunk of the network. And there was a human in the way, but of course that human had been pressing go for the past 7 years and nothing had ever gone wrong. Vent radioactive gas, yeah, just keep doing that. So we, as far as I can see, we keep just sabotaging ourselves. And Rob asked me the question, what is it that keeps me awake at night? And I started making a list, and I went, okay, the first thing that keeps me awake at night is business failure of a crucial provider. This has happened. That was a very unpleasant morning. I woke up and heard that a certain provider was in chapter 11 or something. Then there's the single points of failure that we don't know about, that we probably should know about, but we can't find out about because we can't get the maps. And then there's the fact that everyone seems to concentrate all the traffic in very particular areas. All the videos on the internet are on YouTube. and very large chunks of the images in the internet are on Akamai or on other CDNs, then I worry about DOSs that happen at a really, really bad time. A really bad time for me would probably be 6 o'clock this afternoon when the Apple keynote's on, but other people have other events which are more important to them, and it's probably those we should be worrying about. And it's only then that I make my way down this list that I get to what I lovingly called the creaking, cobbled together miracle of adequacy that is the global routing mesh, and start thinking about things that we can fix there. And it seems to me most of the really, really scary problems we face are business problems. They're the business decisions that people have made, and they're going to require business justification to change. Technology solutions can go somewhere, but only as enablers to that business justification. Really, I see that I could probably cope better with a lot of the problems we have if the internet was actually a bit more distributed, but it isn't, so we're left trying to cope with that.
All right, thank you. So before we start looking at maybe some of the solutions to some of these problems, are there other problems that those of you in the audience would want to add to that list? Problems with internet routing, the stability of internet routing? No? Okay. So we've had problems. How do we get around these? Where do we move to next that solves some of these problems or gets the internet into a more stable place? And I'm going to go through each in the same direction again. Mike, please.
Well, I'll come back to something that Dave just said. We haven't rehearsed this at all. I'm going to come back to something Dave just said, which was about the business implications. We've got things like signed origin is the most likely thing to happen in terms of root signing. Well, it is happening in terms of root signing, but there's going to be training involved, and getting it through to businesses that may need to invest in their staff and train their staff is a significant business concern, because particularly in a smaller business, there's only like a handful of network guys, and you can't actually afford to let them all go on training courses all at once, or even enough of them go on training courses, and then also trying to relay that, because of course and it's almost back to the discussion about V6 that we had earlier. Well, we deploy V6 when we need it, and to the people that are running the business and that are in control of the money, they go, well, do we need to deploy that now? Do we need to train people on this now? Do we need to do that now? And it's always kind of, in terms of business and running a business, you want to sometimes defer expenditure unless you can see what the return is, and you can see that if I spend this money now, I get this return here. If that message isn't clear, then of course, if you've got the purse strings, you're going to try and defer spending the money, because that's what you do when you're running the finances of a business, and you try and defer expenditure if you can avoid doing it. And I think some of us here are fortunate to have worked for organisations that are more engineering and more technical led. If I think about my long time at Lynx, it's a very technology-led organisation, also a member-owned organisation. So its dynamic was very different, and getting authorisation from the board to spend money, it was very easy. I went with a technical justification, we need to do this, and they said, brilliant, okay, you've obviously thought this out, and we'll make sure that we've got the money to do it by setting the fees right. And of course, what would happen is you go to the members and say, here's our capital plan for the next X years or the next 12 months, and we need to charge you this much per port. And that was actually an easy thing to make, but a lot of people aren't in that position, and it's a lot harder to make the case. But then I think, you working for a public body in terms of HEAnet, and you're working for a public body in terms of JANET, you've got the same challenges, if not more difficult challenges, than a privately held business. So I think the sort of money side of this, it's why do I need to do this? And being able to get that message through more clearly to the business, I think, is an important tool that people in this room that have to go and report and guide their organisation strategy on this stuff. That's the sort of useful tool that needs to be, and the useful information that needs to be provided to them in terms of one of the solutions. But it's not a solution.
So maybe the commoditization of the internet hasn't necessarily led to a commoditization of knowledge about the internet and how the internet works.
That's a very succinct way of summing it up, yes.
But, okay, so that's increasing the skills of the people. Is that equally applicable to the manual configuration and the automated configuration? How do we maybe get the automated configuration a bit more...
I think automation has to become in terms of scale. So when you're scaling a business, you look at things that people at Google and large organisations like Google and Facebook, they've gone heavily down the automation route. And dare I mention DevOps? I might get people frothing over here. DevOps is kind of an interesting thing in the sense that it's automation and it's all very real time. But effectively, the other way you can look at it is I can be very rednecked about it and say, it's damn server guys messing with our networks that they don't understand. That's not necessarily my own personal point of view, but if you wanted to be very sort of balkanized about it, you could say, that's what that is, and it's server guys getting into stuff they don't fully understand. And of course, they're getting into things in ways that are not necessarily constrained as well by classic routers in terms of doing things in virtualization. We had the discussion about from the alternative guy yesterday, talking about what happens in terms of virtualization and vSwitches and things like that. So those sort of concerns.
Okay, so Nick, you started talking a little bit about some of the solutions there, some of the BGP, SEC, and SIDR. Do you want to expand a bit on what those might solve, what they might cause?
Just slightly picking up a little bit again on what Mike said. There is a certain argument to say that, well, we need more clue in organizations, because interdomain routing is fundamentally not necessarily terribly difficult for a lot of leaf organizations, but when it goes wrong, it can have a much more widespread impact than one might expect. So from a carrier point of view, the requirement is to try and restrict that impact to as small an area as possible. So sensible precautions need to be in place. It would be really nice actually to see large-scale organizations providing commercial transit services to implement hard prefix filtering on all BGP announcements. Some of them do, some of them don't, but it is actually quite important. From an automated point of view, RPKI, well, yes, it can help, and it will help from a technical point of view. There is the potential for misuse for it as well, and there's a couple of issues that cause me some concern about it. One of which is a very simple issue, and that is that if you've got a sort of a mesh of autonomous systems talking to each other, you have a massively distributed system. And when you have a massively distributed system, if you take out one of these AS, if you manage to constrain the instability problem that you have just to that one AS, well, then that's great. You've kept the problem out of all of the other areas. But if you have a RPKI or root origin validation, you necessarily have to have a feed into your routers which is giving the information about prefix validation, and that introduces an element of sort of top-down control on your routing domain, which is fine in theory. You kind of have the same sort of thing with prefix filters in theory, but prefix filters are not done real time, and you can in theory have problems with or could have problems with real time problems with ROA caches, and if you run into problems with those, well, you can do an awful lot of damage very quickly. And it concerns me that if there are problems at the top apex of a ROA tree, well, then the problems will break everything sitting underneath it. And in that case, you're not restricting your problem to a single AS. You can wipe out an awful lot of connectivity. Whether this is a realistic scenario or not, I don't really know. We haven't really deployed enough RPKI to know whether it's going to happen or not. So those people in favor of RPKI will say, well, look, let's do it and let's see what happens. And if there is a problem like that, well, we'll deal with it in future. There is also an alarming lack of protection from layer 9 and layer 10. This has been mooted on several mailing lists, and it's actually trashed some right policies, or at least one right policy in the past about introducing RPKI. This is a difficult area. Semantically, routing prefixes and RPKI kind of do the same sort of thing. So, I mean, why are we not getting as upset about routing prefixes in the IRRDBs as we are potentially winding ourselves up about RPKI? Well, the answer is routing prefixes just don't work, or routing prefix lists large scale just don't work. So we don't necessarily need to worry about it because we can't deploy them on very large systems. Whereas we think that RPKI probably will work in very large systems. So these are issues that we haven't solved. I'm a little bit skeptical about whether RPKI is going to solve more problems than it causes. Other people disagree, and I think probably the only way to do it is to actually run it in real life and hope that the problems are that we're concerned about are just not going to happen.
So maybe part of that perhaps with the RPKI. Part of that with the RPKI might be that with prefix filters you can quite easily make exceptions. You have scripts that go through things. It's all usually done on a fairly simple basis, but with the RPKI, if a prefix is made invalid by some decision higher up, then it's invalid, and it's awkward to then create the exception.
Once that happens, and once you get a BGP withdraw notice for that, the BGP withdrawal will propagate out through the DFC, and then you're not going to be able to introduce another update for it. And when that happens, okay, well, there's probably going to be a whole pile of networks which are never going to be RPKI enabled. But if that prefix doesn't have visibility into a critical number of ASs, well, then its connectivity is going to be pretty trashed anyway. So, yeah, difficult.
Is a vector that's introducing more entropy?
Potentially, yeah.
I didn't have a mic. What I was just saying to Nick was actually what you've got is this vector that's introducing more entropy into the system. In theory, it'll scale better, but that comes at the cost of that entropy and managing that entropy, which is back to fat fingers or unintentional problems again. So
more entropy, and also something I was going to ask later, perhaps more complexity. And complexity is never a good thing, is it?
Complexity bad, does not scale.
I like my network simple. I'm a simple person. Dave.
There's two tacks I could take here. Since you say complexity, I'll go with that one. We're not the first field to go down this road. If I ask for a show of hands, who would be familiar with or aware of the software crisis of the 1960s? Wow. I am unusual as a networker because I study computer science, and every now and again I'm really surprised that something was relevant. It seems like all the best networkers are physicists, and I get it from both sides because I was always taught that a computer scientist should never be seen near a computer, which is correct, by the way. But the software crisis of the 1960s was, when computers were first invented, they were very limited and became very powerful very quickly, and there was sort of an assumption when it came to writing software that writing software was not very easy, and it was pretty primitive and awkward, but these new powerful computers would make it much easier. And of course it turned out that more complex computers, and in particular more powerful computers, became much more complex to try and write software for. They were capable of much more, their programs became far more complex, and the people writing them didn't. And this is a crisis. It's how are we going to be able to cope with this? We have this capability that we're having enough trouble just even getting this thing to run itself reliably, never mind the applications. And we have all these applications that we could build, but we've no idea how. And this was a serious problem, serious discussion in the 1960s that basically led to, and the solution, you'll be sorry to hear, was the whole field of software engineering. So others have been down this road before us. If we're looking at a state where the global routing mesh is now a very complex thing, and any change we make has all these unintended consequences, there is expertise elsewhere in having dealt with this. You can judge for yourself on how well that went, but certainly there's prior art there. We don't have to work this out from first principles.
So, do you have any comments on that? I mean, is there a way to get around this complexity by where do you see perhaps the process of software engineering coming into of computer science coming into the internet routing system? Is it just adding a layer of redirection like Lisp, or is there a larger scope for a new branch?
I'm a computer scientist. I wouldn't know about software engineering. I don't have the answer here. I think there's going to be some very interesting conversations to be had about this, particularly among people who honestly know a lot more about where it's gone than I do, and the mistakes that have been made there that we could try and avoid repeating. That I think is worth studying. But I'm also aware we have our own limitations as well. The internet today is what it is. There's an argument going on at the moment among Apple nerds over John Gruber's invention, which is Markdown. And some people out there got together and said, what Markdown needs is a standard, and there's a huge argument over this. And one of the answers seems to be coming back to, look, Markdown is not perfect, but it is what it is, and it's deployed. So we should be working off that and not trying necessarily to make everyone standardize on something in particular. Just start with what's deployed and see what we can do from there. We have what we have. There's only so much we're ever going to be able to change about that, and we need to be able to work from there. I think any answer we have is going to be based off that. Of course, as has been seen earlier, I'm now very bitter and cynical about trying to change things. So maybe there's something else to be done there, but I don't know. This is software engineering is an enormous field, and there's probably some lessons we can pull from it, but I don't yet know what they are.
Unless either of you want to follow up on that, I'll ask the audience if they've got any comments on routing stability problems, solutions, new vulnerabilities opened by this, vulnerabilities not yet solved.
Jim Reid from RTFM. I'm just going to chuck a hand grenade into the room. What about RPA, unsecured BGP? Is that going to be a help or a hindrance?
Well, Nick, you started on that. Does somebody else want to follow up a bit more? Or,
Sorry, Jim, I didn't quite hear the question.
Sorry, Nick, the question was, is RPKI and secured BGP going to be a help or a hindrance to these problems of routing stability?
Well, I don't think we have enough operational experience with it to figure it out, to figure out the answer to that question. There are a lot of people who think that it will solve a certain category of problems for them, but you know, it's like a whack-a-mole problem. You fix a problem over here, and then something pops up over here instead. And I'm not clued in or wise enough to know what the answer to that question is. I can see potential problems, but you know, these are crystal ball issues, and there's always going to be a massive difference between what you think you see in the crystal ball now and what actually happens in you know, several years down the line. And once you've deployed it, it may turn out that you know, that no court is going to ever whack a ROA on the head, or ask it that it be withdrawn or invalidated. And it may happen that the complexity that is required to implement root origin validation is an acceptable trade-off for the benefits that it gives. Or it's most likely actually to happen that people will run around and deploy RPKI, or at least a row of validation on the routers, and then they run into a problem which it was never going to fix in the first place. They say a problem that might have been fixed by AS path validation, and then they say, well, this damn well didn't fix my problem for me. I mean, what have we done this for? And you could put that down to ignorance of the problem space or whatever, but it's not going to fix all of our problems. It might fix 30, 50, 60% of them. We've seen a lot of prefix leaks over the past couple of years, and I think we probably always will see them. Maybe this is just the price that we have to pay for the type of internet ecosystem that we have, that we accept that there is a certain level of failure kind of going on in the background, and so long as it doesn't get too much, that's okay, we can live with it. Which, by the way, is actually quite a sensible way of doing things. I mean, we do the same things for money. I mean, we all have credit cards in our pockets, and the credit card companies full well accept that there's going to be a certain amount of fraud, which is going to result in billions of euros lost in fraud every year. They just accept that and move on. We think that that's a very large amount of money. They don't. Again, it comes down to engineering. If something generally works terribly well, but has a small amount of failure that's very difficult to work around, that's probably quite acceptable.
Okay, thanks, Nick.
Yeah, so I think it's all these kind of things are a double-edged sword, aren't they? RPKI and root origin validation, things like that. It's a double-edged sword because it can backfire on you as well. Even going from a simple single home to dual home transit arrangement is a double-edged sword, because you've gone from just receiving default routing and, well, when my upstream's down, I'm down. I've gone to a situation where I've got this, I've got either a default or a full table from two different people, and in some ways I'm protected and in some ways I'm not. Even to the physical layer of routing, when we were talking about earlier, when Neil was talking about BT's network in Ireland, and we're talking about routes down railway lines, are they up both sides or just one side of the railway line? Is that considered redundant? And so these double-edged swords and this element of risk that we're taking on, Nick highlighted an example of an industry that's actually very mature about how it, in terms of how it quantifies how sharp the backside of the sword is effectively, which is credit card fraud. And it can quantify that and say, I'm prepared to take that on. And I wonder if us as an industry are not as good as working out the size of that problem than we should be or could be.
And my answer is, who cares? We don't deploy these things based on our best considered interpretation of the intended and unintended consequences. We deploy them because we need them in a hurry. Why do we have resilience in the networks? Well, NRENs used to not have resilience in the networks in the 90s, because in the triangle equation of cost and bandwidth and resilience, we were erring towards bandwidth and cost. We were using every byte we could afford. Yeah. And then at some point in the early 2000s, that just changed, and it's changed very, very quickly, where people realized if this thing goes down for more than a few minutes, never mind hours, we're in deep trouble, and the whole equation changed. The reason querying quad A records works universally on the DNS system is because bind 4 had vulnerabilities in it, and so we had to get rid of it. The reason we have MD5 passwords all over BGP sessions was because of an advisory that went out, and a week later it was all done. RPKI, I think, is going to be in that category as well, and a bunch of others are going to be in that category. At some point, the incentives are going to align, and the technology that's there will get used, and the technology that isn't there won't. And I think that's just how we work.
Okay, great stuff, thanks.
Right, unless there are any quick questions, I think we're about out of time, so any other panelists want to make a final comment? Or
just to pick up on your one of MD5, Dave, how many people took it away later as well because they found that was, again, another double-edged sword that caused CPU overhead, CPU issues, and God knows what else. So it wasn't what it needed to be.
In which case, if you could join me in thanking Dave, Nick and Mike. Donald, very, very short, very quick. Thank you.
Donald Cunningham from Airspeed Telecom. For those of you, and I understand that this is possibly teaching my granny to suck eggs, or a lot of grannies to suck eggs in this room, on the fat fingering side of things, if you haven't played with commit confirmed on a Juniper, or the Cisco iOS equivalent, even if it's the very dangerous reload in 5 and then make your changes, there are ways to, if not alleviate fat fingering, to at least make the incredible crippling pain in your brain slightly less.
And don't forget to cancel the reload.
Could I just totally reiterate what Donald C. I mean, for God's sake, it's 2014. Why on earth are we still using reload in 5? It is ridiculous.
We should be doing reload in 10.
Yeah, we need time to compile all
Right. Thank you very much.